Hello, my name is Dr. Chloe Stewart, and today I'm going to be talking about my research on the way that our bodies feel when we feel guilty and how this may change in neurodegenerative conditions. The autonomic nervous system, or ANS, is responsible for the largely unconscious regulation of the internal organs. The ANS has two main divisions, the parasympathetic division, which is responsible for relaxation and energy conservation, and the sympathetic division, which is involved in responding to threats. Both divisions operate tonically and complementarily. However, in response to external or internal stimuli, one or the other may predominate. The ANS is responsive to our emotional states, generating physiological responses to emotional experiences. Here you can see how the onset of anger generates changes throughout the body. This bodily activation has been well characterized in basic emotions like happiness and sadness. However, less is known about how it is affected in an emotion that is a little more complex, like guilt. Guilt is the awareness that some type of harm to another has resulted or may result from one's action or inaction. Though it is aversive to experience, guilt is necessary for successful social functioning. Here you can see how individuals who are low in guilt are more likely to commit delinquent acts at work and in their daily lives, while for individuals high in guilt, the opposite is true. A connection between guilt and the body is suggested by frontotemporal dementia, in which the ability to feel guilt is gradually lost, concomitant with unusual or absent physiological reactions to emotions. In the Trolley Dilemma and its footbridge variant, in which one must decide whether to harm one person in order to save others, patients with FTD show less physiological reaction and less emotional distress when compared to those with Alzheimer's disease or to healthy controls. In Parkinson's disease and dementia with Lewy bodies, it is known that the ANS is perturbed, as dysautonomia is a very common symptom of both disorders. However, the extent to which this affects emotions or social behavior is as yet unknown. In this study, we sought to investigate how the body experiences guilt and how this may change in neurodegenerative conditions. We hypothesized that individuals with certain neurodegenerative conditions would display altered patterns of ANS responses to emotions in general, and guilt in particular. We predicted that patients with FTD, DLB, or PD would display altered patterns of ANS responding to emotions in general, and guilt in particular relative to healthy controls and patients with AD, and that this difference would further distinguish between diagnoses, and that patients with FTD would show autonomic hyporeactivity to guilt stimuli relative to healthy controls and other groups, while patients with DLB and PD would show disturbance of guilt correlated with their dysautonomia, and patients with AD would display patterns of activation and experience of guilt similar to healthy controls. 63 participants took part in this study, including 12 patients with Alzheimer's disease, 12 with frontotemporal dementia, 15 with dementia with Lewy bodies or Parkinson's disease, and 24 age-matched healthy controls. They completed a questionnaire about their opinions and behaviors. They then underwent a video task in which pre-generated statements comparing their behaviors unfavorably to peers were presented in advance of videos designed to elicit guilt or one of the comparison emotions, while continuous physiological recordings were taken. Our repeated measures of ANOVA confirmed that the diagnosis and emotions interacted to predict psychophysiological signals. Planned contrasts found that in both the healthy control and DLB-PD groups, swallowing rate distinguished between feeling guilty and feeling disgusted. In the DLB-PD group alone, swallowing rate also distinguished guilt from sadness. These results suggest that this relative change in swallowing rate is a typical response during the experience of guilt, and that this pattern of change is preserved in DLB-PD. By contrast, this difference in swallowing rate was not found for either the AD or FTD groups, suggesting that this psychophysiological signal is perturbed in these dementias. Electrodermal activity, a measure of sympathetic activity based on the amount of sweat the skin produces, was useful to distinguish between the diagnostic groups. Electrodermal activity was found to be lower in the healthy control and DLB-PD group, indicative of sympathetic withdrawal. Again, the AD and FTD groups differ from the healthy control and DLB-PD groups, suggesting perturbation of the typical skin response of sympathetic withdrawal in those disorders when experiencing guilt. Despite these autonomic changes, we did not detect any significant differences between the groups in terms of the number of times they selected guilt as the emotion they were experiencing during the video task. In conclusion, we identified differences in psychophysiology and the psychophysiological experience of guilt across these neurodegenerative diseases and between them and healthy controls. In particular, we identified perturbations in some elements of the ANS responding to guilt in both Alzheimer's disease and frontotemporal dementia, but not in dementia with Lewy bodies or Parkinson's disease. These perturbations were not associated with changes in reported levels of guilt. These findings laid the groundwork for future studies, not only of ANS function and dysfunction in neurodegeneration, but also for more exploration of the way that guilt and other complex social emotions are affected in neurodegeneration. Future research could also investigate ANS responding in children who are developing guilt, in populations beyond the North American context, and in other patient populations with pathological levels of guilt, such as obsessive compulsive disorder or psychopathy. Thank you for your time, and thank you to the members of my lab. I welcome any questions.